Alaikum wa rahmatullahi wa barakatuh, and welcome back to Physics for All. Today we are tracking paper 6, no lab, no problem. I will show you exactly how to secure those practical marks. Let's dive in and say Bismillah. I'll share my screen with you. Give me 1 second. Here is the first question we have here. A student investigate a pendulum, figure 1.1 and figure 1.2. Show some of the apparatus used. Figure 1.1 and figure 1.2, you can see them on the screen. The student adjusted the length of the pendulum until the distance D measured to the center of the bob is 50.0 centimeter. So to the nearest millimeter. State one precaution that you would take to obtain the length of 50.0 centimeter as accurately as possible. It's a matter of skills. And it's like you are going to imagine yourself inside the lab and you are going to take the measurements. The best issue, I'm going to bring a meter rule and let's make a meter rule. Let's imagine we have a meter rule here. We are going to assume this a meter rule. Here is the 0 of the meter rule. And then here is the midpoint. I'm going to add a mark on the pop and I'm going to put my eye level perpendicular to the scale. So here is the eye level perpendicular to the scale. In order to be sure that it's perpendicular, I'm going to use a set square. It's better to use a set square. Here is the set square. Okay. To make sure that it's perfectly vertical because I'm measuring a height. Then by putting the eye level perpendicular to the scale, you are taking the most accurate way because there is no parallax error, to avoid parallax error. So put your eye level perpendicular to the scale to avoid parallax error. This is the first mark. The student displays the pop slightly and release it so that it swings. Figure 1.2 shows one complete oscillations of the swing. So he pulled the pop to the right for a certain distance or to the left, it doesn't matter, and he left it to swings. And of course, when it passes by the equilibrium, like when it goes to the right and then pass the equilibrium to the left, and then when it returns back, so we are going to say that there is one complete oscillation. He measured the time t small for 20 complete oscillations. So t small is the total time of 20 complete oscillations. The time t is shown on the stopwatch in figure 1.3. So 27.6 seconds. Take the time of 20 t small, the time of 20 complete oscillations. In the first row of the table 1.1, record the time t shown in figure 1.3. So we are going to go the table 1.1 and the time t here, which is 27.6. 27.60. So I'm going to write it like this within two significant figures. In order to have the same sig fig and the same decimal place in the column, as you can see here. And then all the numbers here with the same, in the same column, with the same significant figure or the same decimal point, it is matched with the same significant figure and also decimal point. Then T capital. Calculate and record in table 1.1 the period T of the pendulum. The period is the time of one complete oscillation. T capital, you know that T will be equal to the time of 20 complete oscillation divided by 20. So what is the time of 20 complete oscillation? 27.60 over 20. Let's make it on the calculator. So here is the fraction, 27.6 divided by 20 equals 1.38 second. So the period is 1.38. Also, 3 significant figures and 2 decimal place matched with the same number in the same column. Calculate t squared, record the value in the table. So I'm going to return back to the calculator. Here is t squared, the answer squared. 1.90 t squared, 1.90. Okay, now I have all the raw data in the table. The student repeats the procedure in PE using D equals 6 centimeter, then 70, 80, 100 centimeter. The readings are shown in table 1.1. Plot a graph of t squared per second squared on the y-axis. Directly, I'm going to label y-axis by t squared per second squared. 1 mark. It deserves 1 mark, of course, by against d per centimeter on the x-axis. So d per centimeter on the x-axis. So I label the axis of the graph and it worth 1 mark out of the 4 marks. You don't need to start your axis at the origin. Great, he gave me a chance to not to start from the origin. So we have a fake origin right now. I'm going to bring my ruler and I'm going to draw the axis. Here is the first axis, the horizontal one, the x-axis, and here is the y-axis. Okay, and they both labeled. The distance is easy, 50 till 100. So how many divisions do we have here? 1, 2, 3, 4, 5, 6 divisions. And here we can put the 7th one. So we can start from 50 till 100. So if I made it here, 0, here is 50, here is 100, here is 50 till 100, 50, 60. So we can make it 40 here, 50, 60, 70, 80, 90, and 100. The distance per centimeter. Regarding to t squared, the smallest number is 1.9 and the largest number is 3.9. It's around 4. So we have, we can put 1, 2, 3, 4, 1, 2, 1, 2, 3, 4. If I made it here 0, here is 1, here is 2, here is 3, here is 4. And we have 10 divisions in between. So 1.0, 2.0, 3.0, 4.0. The number will be from 1.9 till 4. If you look like this, you will see that it is not an accurate. It doesn't cover 50% of the graph, the distribution. So I need to extend it more. So we can start by 0.5. It will be better. If we started by 0.5, for example, 0.5, 1.0, 1.5, 2.0. Now let's go to the t squared. I'm going to remove the ruler. The smallest number is 1.90 and the largest number 3.96. So we can start from 1.5, 1.5, and here 2.0, and here 2.5, and here 3.0, 3.5, and 4.0. If you look here, we are going to put starting from here till there, so it covers more than 50%. So I think this is better distribution. It's a very good distribution because the distribution of the values on the y and x-axis cover more than 50%. Let's put the dots. We have either the plus sign or the x sign or the dot, but I prefer to put the x sign. I'm going to make my pencil is the smallest, and I'm going to convert into black. It will be better. and let's put the first point. 50 with 1.9. Before we go here, we need to find the difference between these two. The difference between these two, 1.5 and 2, it's 0.5. And how many divisions? We have 10. So the smallest division is 0.05. So the smallest division here in the vertical component, the smallest division is 0.05. 1.9 is after 1.5, pi is 0.4. So 0.4, if we are going to divide 0.4 divide by 0.05 will give us how many division after 1.5 exactly. So I can use my calculator again. So 0.4 divided by 0.05 is equal to 8. So 8 division. 1.5 after 8 division will give us, so 50 was 1.9. And then we're done with the first row, the second row, 60 was 2.25. 60 was 2.25. So 2.25 is in this area. It's after 2. So 2.25, 2.25 minus 2.0 will give us 0.25. If I'm going to divide it by 0.05, will give me 5. So it's actually after 5. So 60, and here is the second point. I'm done with the second point. I'm going to clear space for me for my calculations. And then I'm going to the third one, 70 with 2.76. 70 with 2.76. 2.76 minus 2.5 equal 0.16. 0.16 divided by 0.05, almost 3. So I'm going to move up by 3 to 1, 2, 3, around 3. Almost 3 points. Okay, I'm done with the third dot. The fourth dot, 80 with 3.2. 3.2, it is here. So 3.2 minus 3 will give us 0.2. 0.2 divided by 0.05, it's like 4. So I'm going to move by 4. So 80 with 3, and after 3, 4, 1, 2, 3, 4. Then I'm going to make a space for my calculations. You can use your eraser in the exam, it's okay. 100 with 3.96. 100 with 3.96. 3.96 is here, so 3.5, 3.96 minus 3.5. What is the difference between them? It's 0.46. 0.46. 0.46 divided by 0.05. 0.46 divided by 0.05 equal to 9.2. That's like 9. So 100 with 9. So it's here above it with a little bit. So I'm done with all the dots needed in the exam. Plot a graph on the axis, no need. Determine the gradient. So we need to draw the best fit straight line in order to find the gradient. I'm going to look to all the points. I'm not going to take this 3 point, and I'm going to ignore the other up to, no. I'm going to draw a straight line that is symmetry between the upper dots and the lower dots, with symmetry between all of them. So I think this is better. And I'm going to draw a thin, straight, continuous line. And then I'm going to make the gradient, or find the gradient. I'm going to change the color of the pen, and I'm going to choose, draw the largest triangle you can draw. Here is the first point. and here is the second line. The triangular method is must here. And here is the first point. Here is the second point. Here is the first on the y-axis, and here is the second on the y-axis. So here is y2, and here is y1. Here is x2, and here is x1. Finding the gradient. Gradient is the difference in the y-axis over the difference in the x-axis. So delta y over delta x. Delta y is what? 3.5 minus 2.0 over. And for the x-axis, 90 minus 50. 90 minus 50. So I'm going to put this all on my calculator. Here is the fraction, 3.5 minus 2.0 over 90 minus 50 equal 37.5. So I'm going to round it to be 38 times 10 to the power of negative 3. 38 times 10 to the power of negative 3. You don't need to write a unit for the gradient. So it's like 0.038, or you can put the unit. So it will be second squared per centimeter. It's okay, but actually there is no need, but it's okay. Calculate the acceleration of free fall, g, in meter per second square using the equation g equal 0.395 over g capital, where g is your gradient. Write down the value of g to a suitable number of significant figure for this experiment. So here you will find that significant figure is very important. Okay يا شباب, let's do it. We have g is 0.038, the gradient. Let's substitute for finding g. So g is equal to 0.395 over 0.038. Let's put it on the calculator. Here is the fraction, 0.395 over 0.038 is equal to 10.3. So I'm going to write it as 10.4 meter per second squared within 3 significant figures. All the number are within 2 or 3 significant figures. You can write it 10, or you can write it 2.4. 2 significant figures or 3 significant figures are accepted. Don't worry for this. And that's it for the paper 6. And I wish you will record the full mark in this paper. And you observed that we covered how to draw the graph and how to write the right significant figures in the final results, the unit with everything, labeling the axes, the dots, the best fit line. I wish you all the best, and wait me for chapter 2. Assalamu alaikum wa rahmatullahi wa barakatuh.